Gentlemen, Dr. John Belkowitz here. I'm excited to talk to you today about one of our Q&As. It's a concrete coffee talk, if you will. Whitney's got the kids downstairs, and I got a few minutes just to relax and talk concrete with you. So one of the questions that somebody asked me, I met somebody in a restaurant, and we were talking about one of the videos. It was the hydronic cooling or the hydronic temperature control, especially for cold weather concrete. And the question was, what is a cold snap? And I use that. I use that oftentimes in a lot of my talks. I use that a lot of times in my talks, especially when we talk about hydronics or chemicals to make your concrete more resilient to these unpredicted drops in temperature. So a cold snap to me is just that. Now, there is no temperature range. In Austin, Texas, we've been working in 80 degree, 70 degree weather, and then out of the blue comes a 30 to 45 degree day. Now, despite the fact, let's just call it a 45 degree day because that's really what had happened, and despite the fact that we're not freezing yet, that still changes the way that concrete is going to move and shake and make and cure. Concrete has a certain activation energy, so it has a certain energy at which the thermokinetics of cement hydration start kicking off. If you reduce the temperature so that the concrete itself cannot start kicking off reactions, or the temperature cannot induce those thermokinetics, that activation energy does not get reached, and well, the concrete effectively falls asleep until it reaches that activation energy or that maturity over time. And there are times that it will gain strength with no problem, but there are times, if it's cold enough, if there is a freezing condition, then you can cause some irreparable damage to your concrete structure or concrete element. We did a whole thing on hydronics, and we did a slab that was cured with hydronics and a slab that wasn't cured with hydronics, and we had a negative 20 degree evening, and we came back and had a 6,000 psi with the temperature controlled, and with where it wasn't temperature controlled, we had 600 psi. So not taking the right precautions can be a very, very expensive measure. But that being said, when you're dealing with a place like Austin, Texas, where your coldest snap, I think last week, is either 40 or 44 degrees Fahrenheit, you might not have to worry about the freezing of water, the expansion, and the issues that are caused because of that. Now, let's say we come here to Colorado, where we can have a 70 degree day and a negative 20 degree night. And that's 70, it's Fahrenheit, by the way. That's not crazy. I remember I was doing a job site. It was when I was working for Lafarge North America. This is years ago. And one of my bosses came in from France, and we were doing a very specific concrete for road pavement or for road replacement. And it gave you 2 hours of workability, and 2 hours after that, you got 2,500 to 3,500 psi, so you can open it up to traffic. Which that type of combination of things was unheard of, but it was all based on temperature. It was based on 10 degree temperature increments, which we're going to talk about later on, or during another video. Anyway, so John Michel came in, and we got it was 70 degrees out, 75 degrees out. We ordered the truck, 5 yards. We had a nice form set up so we can get everything, shoot it into the form or discharge into the form, finished off, and then 3 hours later, because we were right at the plant, or 3.5 hours later, we were going to test it out. And it went from 75 degrees, let's call it 70, let's be a little kind to the weather, to 30 and sleeting. And this happened between the time of us ordering the truck to getting the truck to the ready mix shack or to the quality control shack. So the concrete totally fell asleep. It finally set up the next day, which was 18 hours later, because we had hit such a cold snap. So here now, it didn't ruin the concrete because the concrete actually had accelerators in it. We threw blankets on top of it. But yeah, it started sleeting out. So here in Colorado, we're going to have a different cold snap, but it's still that unpredicted reduction in temperature. And if you're going to, somebody asked me, I think it was 2 or 3 days ago, what is that reduction in temperature that we really need to be worried about? And I call it anytime a 10-degree change in temperature, especially when you start getting below the 70s. Now, I don't really start getting worried. Now, we're going to go over measures to take, but I don't really start getting worried until I start getting into my 50-degree Fahrenheit range and then my 40-degree Fahrenheit range. That's when you really want to start dusting off the generator, the heating elements, maybe get a garbage can out, put some water in there, start heating up some water with some pumps, and then get your hydronic system and definitely make sure your chemicals are in there, especially if you're going to get into the 30s. When you start talking below the 30s, like I said, we're going to get into some more measures, but that cold snap can be just a 10-degree temperature shift. And that's not an ACI, that's not a PCA, NRCA, CRMCA, none of those. That's me. That's Dr. John Belkowitz and the work he has done over the last few decades and what I have seen. Now, normally when I design, at a minimum, I design my concretes, especially if it's a specialty concrete that's based on, chemicals and temperature. I base it off of 10-degree temperature changes. So, yeah, that's my definition of a cold snap. Hopefully you learned something. Let me know if you have any concrete questions, any concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete! It is hot!